Alright, find f prime of x. We're going to have the bottom times derivative of the top. Now you can use the quotient rule, the product rule here, but you don't really have to because you have a constant. So it's going to be 4 times the derivative of e to the x, and we know the derivative of e to the x is e to the x, so it's going to be just 4e to the x. So bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Simplify my next step. I'm going to have 4x squared e to the x plus 4e to the x minus 8x e to the x all over x squared plus 1 squared. Combining like terms, there are none to combine, but it's a good idea when you're dealing with e to the x's, it's a good idea to try and factor out the numerator if you can. And so what I'm going to do, I know there's a factor of 4 in every term, and there's also an e to the x. So I'm going to take out a 4 e to the x, which leaves me with x squared plus 1 minus 2x all over x squared plus 1 squared. And I can also, if I try to simplify this, it may or may not simplify, but the x squared plus 1 minus 2x, if I rearrange that, that is factorable. That's x minus 1 squared. And unfortunately in this case it doesn't help us cancel anything, but when you are analyzing a derivative and you're trying to find out where that derivative is equal to 0 or where that derivative is undefined, it's very helpful to be able to factor your answer. So this is your final answer here. This is the derivative of our original function. Okay, these last two problems are problems that I want you to use just different notation. And so the derivative of u over v is v times u prime minus u times v prime all over u squared. All over v squared. And again, this is a case where we know that u and v are functions of x. We just don't know what those functions are. And so problems like this really help you kind of understand or practice using the notation of the derivative. And so the first one, we've got, it says find the value of the following derivatives at x equals 2. So we're first going to use the quotient rule for the derivative of u over v. So the derivative of this is going to be the bottom, which is v, times u prime, minus the top, which is u, times the derivative of the bottom, which is v prime, all over v squared. And so since these are a function of x, you can stress that by using v of x, or in this case v of 2. So we're going to rewrite this as v of 2 times u prime of 2 minus u of 2 times v prime of 2 all over v of 2 squared. Okay, so this is notation. This is function notation, not multiplying v by 2. Now I go back and I look at the values that are given for each. So v of 2 is equal to 1. U prime of 2 is equal to negative 4. Minus u of 2, which is equal to 3, times v prime of 2, which is equal to 2, all over v of 2 squared, which is just equal to 1. And I can simplify this just by doing the arithmetic. Simplifying the numerator, it's going to be negative 4 minus 6, which would be negative 10. Okay, and the last one, I've got the derivative of a sum, and within that sum I also have a product. So we're going to have the derivative of each of those terms. So the derivative of 2u is 2u prime the derivative of 3uv is going to be first, so 3u times v prime plus v times the derivative of 3u, which is 3u prime. And again, since we're dealing with u of 2 and u primes of 2, I want to find the derivative at 2. I'm going to rewrite this in function notation. So 2u prime of 2 3u of 2 times v prime of 2 plus v of 2 times 3u prime of 2. And so we'll fill in all the values. So substituting in all the values, we're going to get negative 8 plus 18 minus 12, which gives us a negative 2. And again, I like these problems because they, without actually having a function, you can really demonstrate that you know the quotient rules and the product rules and how to work with the notation of calculus.